When I graduated from college, I had never been to she took me to New York there are things aren't as important as the memories you are.
She said to Gina.
She does. She has two girls. One is in New York City. She works for the doctor. A lot of research with stem cells. And she may be starting to go to some of the other offices across the state. These work with the Dental Association, almost against the position, and she's a where's the one
bring you down to.
all right, well, Bertha, I'm heading to fix the phone, but we got Sharon on, what is she gonna do with her tomorrow? Who's lucky to have her?
But I don't know if they're referring to the unit or to the.
It's got hard to get in here, and Chip and I are on our second meeting, but maybe if I can squeeze, are y'all doing all that?
Yeah.
Okay, so that would mean if I could squeeze in maybe after one.
So does that mean we're gonna done at 12:30 because I haven't called her yet? I'm just gonna do it, but I didn't. Yes, she did. Sharon's gonna take my.
Here's the
All right, well,
Thank you for coming.
You'll have to let me know how it goes with the
I only changed like a couple typos.
Okay.
So it does say typos, and then
I like the was received twice.
Online.
Talk about it. Okay, well, that there's one that's a little harder, one that's differentiating. And then on this one, I just.
Yeah, that's got the business assessment. I don't know.
So they see that would look better too.
If it's on.
That I just wanted to know if you show up. I think you do. Is it slide? That's how to delete it.
The next day.
I'm not good. Is that correct? That's a there. Right.
There's yellow. You got stuff? Cool.
That's what I want to do.
If you are fascinated with scientific stuff, that's, it's just a cool place. You're standing in bowls and boiling.
You want them to connect that
Really
account?
just a-
I did, I had like 3 minutes there.
And
Because
this
I was gonna smile.
either me.
Like, do they?
I know. This is
They
man,
want to see it.
just floating along there. And well, he doesn't guide, we had a guide, everything.
And the same video, that's the one I was thinking too.
I was thinking about it on the weekend. Somebody gave us ices today, and I think it's still on my shirt. It's totally right there. I didn't notice all that. I don't know how to. Yeah. Tomorrow, so that's what I'm doing.
The self-protection document and.
And my hat.
One of my parents, they said it all, she didn't have any Alright, so it's all like a soft snap, I really, I know, it was literally. No, that's not what I'm talking about. Yes. But I don't know if you want, good, and then, I'm like, hey, I was about to pick that up.
No way. 3D? No way.
I gotta read it. I'm sorry.
Oh, yeah, that's the one that we like your own, like you just make it and like each slide has a, I do the first
That's like your favorite today. Oh, I got you.
And motion detectors.
It may not.
Not this one.
If you need, if you ever need any training, let me know. I'm
Sorry.
It doesn't have
Hold on, let me highlight it.
Don't be like synopsis in the beginning.
But they're using their.
Would you like me to do the even
smarter than
and then you get, And then get
Oh, you were,
it.
I think you are sponsored.
And then get it.
But we were,
We're
oh, you look good. Oh, I see.
We don't even have that on there. They're all.
That's your dad. Oh, that's you.
I'm going to.
I don't know why. Oh, you look just like your dad.
Oh, you.
So Jerry, how are you? His, he is, he's a harbor manager in civil engineering. But he's got a heart for civil
Are not ready. And then a self-reflective document from a beginning and reflections.
He is part of this.
And then this one is really long here that has stuff about. Yeah, this was the impact. It's part of the. It's got like. And number 6 says. Yeah, we are.
Have to leave my glasses on, so please. We ready? All right, we want to welcome everybody to our final night of the STEM Fellows for 2017-2018. This year we have been running two elementary school STEM Fellows groups writing curriculum, one middle school group and one high school group. But before we get started with your presentations tonight that we have, seems like long been awaiting, Middle Georgia RESA has a couple of presentations we'd like to make. Jamie, if you would come up here, please. Oh, yes, ma'am. All right, this is for Jamie Cook. He is the reason we have STEM Fellows. One Robins Air Force Base. He is our for engineers. He was our connection to the Dayton, Ohio project, and so he is the reason we're all here. So Jamie from Middle Georgia RESA, we just want to say thank you. Much appreciated. Last year we had STEM Fellows sort of piloting and exploring the journey with us. We have two STEM Fellows here tonight who were with us last year and agreed to come back this year to lead and support you all through your journey. So we want to say thank you to both of them. Mark. Mark is from Alex too, and we so much appreciate what he's done. And he doesn't know it, but what he will continue to do. Gina Clark is Peach County High School. And bless Gina's heart, I just can't tell you how many times we call her name and say, Gina, would you help, would you help, would you help? And she says yes, so thank you so much. We also have some additional engineers who have been working with us this year. Michael, if you want to come up. It's so funny, the first couple of times Michael was here, he was like, okay, well, I'll work with this group, but I don't mind working with this one and this one and this one. And so almost every night that we were here, he sort of rotated through all of your groups. So Michael, we just want to say thank you very much.
And he had to put up with us.
Oh yeah, he had to put up with the high school people. All right, for our higher education partners, they have been very, very devoted. Celia worked with us some last year, and she agreed to come back again this year. So, Celia, will you come up here, please? Fort Valley State University.
Thank you.
Thank you. You know we're going to call on you again, right? All right, and Jeff? Jeff Hoffman is a new addition to our group this year. He came one time from Central Georgia Technical College, and he said, oh, I like this. I'll keep coming back. And we said, yoo-hoo. Thank you so much, Jeff. All right. All right, and so our first group tonight is a group we call Elementary Number 1. So if you all want to come on up.
Can I say something?
Yes, you can.
In case you didn't hear, we're on YouTube now, and if you want anybody to watch this, the YouTube link is on the agenda. So just copy that and send it to
Except they can't use their technology.
Oops. They should hurry.
Yeah, you should hurry. All right, everyone has their feedback form, correct? So you are to take notes during each presentation. Then at the end, you're going to enter your notes into an electronic platform so that each group can receive their own feedback. Okay?
Our project was on, the unit that we developed was on building a miniature hydroponics garden. And again, Christy, Heather, and Amanda are the workhorses of our team, and were instrumental in actually building this unit for the STEM curriculum. Again, our theme or hero of our project, because this is for third graders, is Captain Hydro. Y'all say Captain Hydro? Captain Hydro! All right. And for third graders, that's exciting, and for us, it's just fun. All right, to be a hydroponics gardener, the objective is for students will work collaboratively to design a hydroponics growing system. They actually get a chance to do this. And how can students build a hydroponics garden out of recyclable materials? The standards that we use are math, fine arts, earth science, social studies. And the math ones deal with interpretation of products of whole numbers and integers. The fluently adding and subtracting within 1,000 using strategies and algorithms, that math competencies for that. General measurements and measure to estimate liquid volumes as well for the math competencies. And then the fine arts is their ability to present. It's okay to have your findings and what you have, but the ability to use fine arts to put together things like the poster boards and PowerPoint, these kind of things like this. The earth science to obtain, evaluate, and communicate information about the physical attributes of rocks and soil, and plan and carry out investigations to describe properties about the growing systems, including the soil. Obtain, evaluate, and communicate information about the similarities and differences between plants, animals, habitats found within the geographical regions, and specifically where we are. Social studies to define and give examples of the 4 types of productive resources. That's natural, human, capital, and entrepreneurship. So these are the kind of skills that we want to specify that the students can apply with regard to hydroponic systems. An overview, we're going to give a pre-test, and we also do give a post-test at the end. We introduce the topic to the students. The engineering design and prompt that we're using for this unit, Jeff, really cool name there, lives in New York City and doesn't have a lot of space to grow a garden. He'd like to grow enough lettuce and herbs to make his salad each day. Your challenge is to describe and develop a model grow system that requires little to zero space to fit itself in Jeff's kitchen or on his rooftop terrace. So it gives the students, those 3rd graders, a framework by which to look at. The other aspect that we explored with this is what can you do with this later on in life? Linking passions to a profession. So some of the career connections that we explored was a hydroponic growers of master gardener, hydroponic equipment salesperson, and the marketing of such. And then career and technical were soil scientists, landscape architect, hydrologists, and 4-H programmers. These are some programs that the students can be steered into, and there are also career paths.
Okay, so that brings us to our engineering design challenge. As Jeff said, we have a prompt. So our students are challenged to build a model, a prototype of a hydroponic grow system for his rooftop terrace or his kitchen. We did develop a rubric that the students would be assessed by. These students will receive a variety of materials, a variety of different types of soils, the soils specifically in the science standard, so that they can kind of play around with and see which ones work better, some that wouldn't work. They'll also be given different materials for wicking that might work, might not. They're just going to be given a variety of materials. They can choose their materials to build their system. They're going to plant a bean seed because they grow really quick, and they'll be measuring those throughout the course of the unit to see if it worked. And as they're learning throughout the unit, they'll be able to make reflections based on what they're noticing and what they're learning. Oh, well, that's why it's not working. I didn't use the right soil, or I didn't use the right wicking material. The volume of the water is not correct. So that's what we're hoping for. We're wanting to see their connections that they're making with math, with the volume of water, the types of soils that they're using. And these are some of the things they'll be assessed on. Did they use the correct wicking material? Just kind of giving us an idea. They will have a chance at the end of the unit to completely redesign after what they've learned throughout the unit, or to make improvements to their design. And these are some of the materials that they will have. There's a lot more in the actual unit. We just put a few of those on here. And they'll determine their own materials.
All right, our unit is 11 days, but it can be condensed into maybe 5 or 6 days. if you put some of the lessons together in the same day. We opened the unit talking about regions of Georgia and the soils that are found in the different regions. To get started, the students are going to go on a trip around Georgia, and there'll be multiple groups that will talk about the Piedmont region, the coastal plains, and so on. They're going to use QR codes, a QR scanner, to go on their journey. And to differentiate the instruction, there are two different links that can take different, the one link will be a little easier, one will have a little more complex, and it will take them around where they'll document, and they'll have a travel log to document the different types of soils and plants that grow there. No, you're fine. And for the fine arts portion, to connect with that, they're going to have a blank map of Georgia. They're going to have the different soils to manipulate and play with, the clay, the loam, the topsoil, and they're going to map the soils on a blank map like this, and they'll put them where they will find them in the state of Georgia.
All right, then we're also going to do working with volume. Students are going to manipulate different types of containers. They're going to look at them. They'll have the liquid in them, but they'll be different shapes and sizes. And they're going to have some discussion. Is this one got more in it than this one? Based on what it looks like. And then they're going to estimate. They're going to say how much they think volume it has in it. Then they're going to do some measurement and actually find the volume of in the different containers, and there's going to be 4 containers, and they'll collect them on this sheet. Then we'll also go into the wicking and the absorption. They'll get a bunch of different materials, graduated cylinders, water, coffee filter, string, just different types of materials, and they're going to get to explore and find out which one works the best. And as we're exploring, they're going to find that a particular wicking material works better than the other, and then they're going to make reflections in their STEM journal about which one did they use and why, what would happen if they changed it and what improvements they might make to their design.
And they're going to do some informative paragraph about detailing how to make a hydroponic garden using the materials that they have. And then they will have to basically just explain the different steps about how to do their hydroponic garden. Okay. And then on the entrepreneurship side of the same thing, they are going to have to do a visual, so it could be a poster board or it could be a PowerPoint, really what their group is comfortable with. And they are going to have to sell their hydroponic system to their classmates. The classmates will have a rubric to kind of grade them on how their salesmanship went, and basically how they are heard, if they're making eye contact, and so on. And that can also be videoed using like the Seesaw app or something so that others can see that. I don't know. But we also have another lesson where they have to do the natural, human, and capital goods. And they have to, the teacher will read a book with them. They have to identify the resources found in there. So they're reading about how to make a garden and all that. So they have to identify if it's a natural good being used or a capital good. And then they will also then have to draw and label their hydroponic garden, the process, and what part of their hydroponic garden falls underneath those goods. So.
One area that we wanted to highlight with the students in the local area down in Fort Valley is the Pure Flavor hydroponics factory that they're building down there now, which will be the largest in the southeast. So, and it should be bringing in 500 million a year to our area here, and they'll be hiring 200 of our students. I say our students, these third graders, they grow up, hopefully they look for a career in there. So there's a applicability, and also there's a goal to their learning. Any questions on anything we talked about? Now's the time. Yes.
Can you put it on the original slide?
First, she asked you to go back to the standard slide. You want to do that first?
Okay, just do the picture, I think.
Picture right there.
Yes, I think so.
All right, the standard slide?
Yep.
Okay. Welcome. Did any of y'all teach it? I'm actually doing the engineering design challenge on Monday. Yes, I'm very excited.
Any other questions? Thoughts? Reflections?
Positive vibes.
Positive vibes?
Would it be appropriate after you teach it to share back with the group?
Yeah, totally.
What experiences you had once you put it into practical use?
Sure.
I thought it was good. Great job.
Thank you.
Whew, thanks. Oh, I'm so nervous. Thank you. All right, now I feel better.
Okay, wait. Thank you.
All right, so you can enjoy. Congratulations.
So I guess I'll just, there we go. Thank you.
I was Oh, I will. I'll email you or text you about it. I'll send you a picture. Maybe you'll find out. And then we'll take a selfie. But I'm way up. Yeah, I'm way I'm gonna die. I won't say work my way to get back safe.
Ready to survey. Ready to survey.
The survey is linked to the agenda also.
How would you search it?
Oh, like that's way.
Tiny URL, tiny URL. MGRESA.
Is this on my?
I checked that for my meeting. I'm sure I haven't seen it.
Like.
You're not learning required. It's not
We don't need to share that with everybody else. We want to know if they're already on.
Only at the very end.
Revalidate ours. Say all fours. I was there.
So they'll do, I don't know.
Try to complete the survey within the next 10 minutes. So we can move on. Make sure you completed that survey.
Whatever we
Fine. 4 seconds away. Where do you see and be there.
That was me talking, right?
I'm sorry.
Yeah.
I'm looking at.
And I saw you later.
Well, there's the internet, y'all. Hey, why didn't I say This is what came up on the internet. Oh, you can okay, ready? I'm like, I'm like, so I'll introduce it as the perfect storm. This is our light and sound flickering, blah, blah, blah. What is there? Well, what do you do? What do you learn? I don't understand. Unit overview, then I'll be jumping into this thing on, we'll tag team on SQF, and I'll just kind of go through and talk about each one. We've got here, published and advanced in, on and off areas. We want to try what many of those, and, then learning targets will be career connections to Shell.
There's one on the back.
Less many activities.
She said something earlier, I said, what's it?
Yeah, that's what I'm saying. I'm just gonna go through things that we want to let go. And then.
Yeah, really do. Touch, sight, smell.
What if he doesn't fly himself? I'm ready. I'm gonna read. Look, it don't. Right now, we
All right, we have 1 minute.
1 minute.
And we're ready for the next group. Jerry, you know the.
Places like that, California or Colorado. According to Jamie, middle school is next.
High school.
You say one, I'll say one. I do think it's over. There's one it's not anything, I'm smart.
All right, every Nicholas Park.
Really good.
That's what I'm
All right, everybody put their technology away.
I don't read Nicholas Mark.
Focus on the middle school and here, I was on the submarine.
Put this here so you can see. Make sure it's from the. Try to stay in frame.
They have frogs. That's frogs. Yes.
Make sure you share your presentation, anyone with a link in the view so you can get to it up here. Make sure you share your presentation.
Y'all ready?
How you doing? You got it? It should work now. You should be able to pull it up now. There you go.
She's doing them next week.
All right, so this is our presentation. It's called The Roof is on Fire. I'm Chair McMillan, Thompson Middle School.
Tisha Chase.
From Howard Middle School.
Martin.
So, our project is where students will design a roof misting system to help cool off the roof of their school, which will help them eventually save energy. Because what happens is that since the roof is exposed mostly to the sun, it absorbs 50% of the heat. So, you know, in the summertime, the Georgia is very, very hot here. So we have to run our cooling systems a lot in the summertime. But if we had a roof misting system, then we can kind of cool the roof, which would eventually slow down the heat transfer, because heat, temperatures of air like to go from high pressure to low pressure. So the cold air always wants to go outside where the warm air is. But if you reduce that temperature gradient, then you reduce the heat transfer. So that's the whole goal of this activity with the Roof is on Fire. So our engineering design project is for students to build a misting system that will collect rainwater, then transfer it upwards to the roof and then mist the roof, helping it to cool off. And again, reduce that temperature gradient that will eventually keep the heat from traveling, keep the cold air from traveling outside, especially during the summer times. So our STEM career connections, we have environmental engineers, project managers, material engineers, and industrial designers. So for our STEM portion, the science that's being addressed, our standards are conservation of natural resources, which is 6th grade of science, and also the water cycle, which is 6th grade of science. For our engineering process, they're building, so they're going through the engineering and design process because they have to build their misting system, test it, rebuild it, retest it. We're going to talk about how they're going to test it in a minute. In math, they're going to be doing, because they have to do a sketch of their school's roof, so they have to do area, rectangles and triangles, values and prisms. They will also be using technology to conduct their 3D sketch. And if they're fortunate enough to have a drone at their school, they'll use that drone to get an aerial footage of what their roof would look like. So it's modeling real world phenomena. So their misting system will collect 1 liter of rainwater and take it up to the roof and mist the roof. So it must collect 1 liter of rainwater at a time, their roof misting system. So in the first 3 days, they are doing activities to get them some background knowledge on the water cycle and the conservation of natural resources. On the 3rd day, they're going to calculate their energy uses, because students don't really think about energy uses in the 6th grade. They have all these devices. They don't pay an energy bill. So they don't really take energy into consideration, but energy plays a huge role in their lives, and the more they can conserve energy, the better off they will be in the future. On day 3, they're going to do a school blueprint. They're going to create a blueprint of their school, what their school looks like for their roof misting system, because then they're going to be given a budget of the materials that they're going to be allowed to use. So once they get an idea of what their school roof looks like, then they'll have a better perspective of how much materials they're going to need to actually build this roof misting system. So that's where the math comes in as well. So they have to make a budget. Their budget gets finalized. And then they're going to do an activity with rainfall calculations, where they're going to use a internet website that's going to show them how to determine how much rain is being gathered whenever we have a certain amount of rainfall in our area. Then on day 7, they'll build a prototype. 8, 9, and 10, they will test their prototype and retest it. So it's a 10-day lesson.
Talk about it, all of it. Okay. A little more specific on the day 1. This is actually, they have an interactive website where they're going to look at the water cycle. And after that, after going through that interactive website, there's an activity called You Are Who Am I, where they have cards where the students, will read a description of a particular part of the water cycle, such as I actually brought that activity group to do it. If they say, who am I? I am the boss of the water cycle. I'm responsible for the wind
who am I? The person with the answer card would say, you are the sun. And then they will read their who am I? And, it just goes around until they complete the cycle. Day 2, they'll be looking at sustaining natural resources, where they will have to, the researcher discuss Water for Life. That's an article that talks about water being the core sustainable resource. And they're talking about ways to sustain water. Then their activity is to build a water transfer device that day. Just a very small device to show how to transfer water basically from one bucket to another bucket. And that distance will be depending on what the teacher decides, how far they need to transfer that water. And there's a list of materials for that day. Day 3, they will actually look at school architecture, sample electric bill, and discuss energy saving methods. They have an energy bill analysis where they have to actually look at the kilowatts, and this is where they're going to look at energy per the unit rate. This is where the unit rate comes in with their math. Also, because they're going to look at the bill analysis and a school blueprint, they'll be looking at perimeter and area. That's also an interactive lesson. The school blueprint that they will look at as an introduction will be a basic rectangle, because with them being in 6th grade, we want to introduce them to the basic rectangle. And it's actually a school from Indiana in 1910 that had all of the restrooms, the media center, everything in that one rectangle. And it has the dimensions drawn out, so they will actually have to take those dimensions and scale it. Day 4, because they have looked at their blueprint, they looked at area, they know about the electric bills and how all of that's calculated, they will actually start looking at budgets, the components of the budget, cool roofs, and mist and cool. They actually have the parts that can be purchased to make a misting system. And for the budget, there's an embedded Excel document that the teacher can use. Also, there is one that is already typed up for differentiation. And there are instructions for students who want to learn how to use Excel. They can get those instructions and be able to make their Excel spreadsheet. And the instructions are also there for them to be able to put the formulas in. So we have 3 different versions of the budget. Scale drawings are next. So they will, after looking at the blueprint of the school and either assessing their school from drone or actually visiting different areas of the school, they will actually be looking at measurements and making a scale drawing. Also, the differentiation here, teachers can allow them to just draw a basic rectangle as their school instead of the different components as a composite figure. Day 6, they're actually, now they know the size of their roof, they will look at how much rain will fall on the roof based on on their blueprint. This is a rainfall calculator, and they will look at the amount of rain that normally falls in the area, and they can just put that amount in the calculator, and it will tell them how much rain will actually fall on the roof their side, so that they'll know if they have enough water to get that liter that they need. And if there's overflow, if there's too much, they have to decide what are we going to do with the overflow of water if we collect more than a liter. 7 through 9 is when they're actually doing the engineering design. They're also testing efficiency back when they do the water transfer. They actually test the efficiency of their water transfer system. I forgot about that part. So then when they do the engineering design process, they will know whether or not if the design that they are coming up with will be efficient. And day 10, they should get to presentations, reflections, post-assessment. ELA, they are writing a persuasive letter to the administrative team, leadership team, to sell their system or to get them to purchase some type of roof misting system for their school.
For the real world connections, we are kind of trying, for sixth grade, we're teaching our kids how to be better stewards of their natural resources. So, and some of the things that we looked at that inspired this project too was that a lot of needs or jobs open in the EPA or other energy industries. So focusing on things, teaching the kids how to discuss things about energy policies, actually looking at what does it take for their school, what are the school needs in terms of energy and what they can do to improve it. And just kind of going from there and working at a school level and then think maybe larger as a community.
Okay, questions?
The transfer system, how does that work? Is it motorized? Is it pressurized?
No, it's not motorized. It's something that they will have to build from common materials, common household materials. So what we do as a constraint is we tell the students, you can only bring in things that you have at home. You can't go out and purchase anything, or you can use anything that we already have in the science room. So they will build a kind of like a motorized transfer system, but it won't be motorized. It'll be mechanically used by the students, and they have to take it from one area to the other area without waste. The goal is not to waste any water. So if they start with, I don't know, 500 milliliters, how many milliliters successfully made it to the other end of the station? How much did you use? So now we're bringing in ratios to calculate percent efficiency.
And then once the water gets to the cistern or wherever it is, how do you make it go out and mist? What's the
or that it's not missing in that activity.
Okay.
It's just basic transferring it from one spot to another. How much can we not waste?
Can you go back to your title? Shouldn't that say the roof? I thought that when I saw it.
So to test their roof misting system, with they actually have a heat lamp and they have wireless temperature probes. So they'll have a temperature probe before it's being misted. They'll collect their data, and then they'll mist it and they'll recollect their data, and then they'll compare the two. So each time they conduct a different trial, they'll get to see. So once they hit collect on the iPads, it'll start just gathering their data automatically for them.
Very good. That's good.
Well,
Yes.
so the design challenge was about creating a misting device. Do y'all build the misting device?
The students build the misting device.
Okay. Have any of y'all tried this yet?
No.
On your design challenge, are they building a scale model, or is this a full size?
Scale
It's
model.
scale model.
Scale model. Any questions? Yes.
Just some food for thought. I love what y'all have with the weather and the rain collection, all that. And there's so many great math tie-ins for that. But another thing, my robotics team this past year for hydrodynamics looked into collecting the condensation water in the classroom from the air conditioners. And they found out that just each classroom air conditioner can pour about a gallon of water down the drain every hour when we're turning each classroom. So that's free water.
Wow.
That's a possibility, but it doesn't have that. Y'all had some great websites for area and all that stuff. It doesn't tie that in, but that's just something to consider to maybe if you ever took it further.
A lot of great water.
I like the possibility you guys have differentiation embedded in all the tasks, like Excel budgets, every task.
Yeah, that's one of their like social studies standards too, is the whole budget, cost and savings. So try to pull that into using their material so they don't just go haywire.
Good job.
Thank you.
All right, so take 10 minutes and fill in your sheet.
You're not going to teach them that song? I gave it myself. I don't think that, I don't want to let it burn.
All right, y'all will be scored.
Oh.
Make sure you're filling out your electronic form for the middle school.
Oh, no, I'm sorry. That's not work out that way, sorry. Oh, my gosh. I'm sorry. So much for your table. It's our table. I just want her mom. I don't want you to. I'm making work for this. I'm not taking my personality. I'm glad. I'm just the way you the real world connections that are connected. And we haven't even mentioned this. I can't, but hey, we're using budget. Just change it keep us rolling. It's been a lot. Right.
Someone just bluntly told me that there should be a comment thing on the survey, so I just added it. From now on.
Artifacts.
Hey, we're just trying to help you grow.
I see.
It's 12th grade. That's all we have a set of
I'll just navigate through the presentation slides. And we're using what I speak.
Yeah, you're right.
Is everybody, all the slides covered there with that slide?
I think so.
Yes, I dropped them off.
I think so. Are we good to go?
I'm good to go.
All right.
I'm not done.
So this is the high school STEM unit. It's geared towards 12th grade, titled Ball of Duty. Up front, career connections, various type of ballistics experts or analysis, aerodynamics, which is a key component in your aerospace engineering, systems engineer. Really, it's a blanket field for a lot of test and development, and then of course mechanical engineering.
Our disciplines, mathematics, so pre-calculus, science is physics, the literacy in science is the CPAE standards, technical writing for English and language arts, and then the engineering for the design. Our standards are, for science, it's projectile motion, and for math, it's the numbers and vector modeling. All right, so for our overview, it's developing an understanding of how vectors are correlated with projectile motion, communicate how launch angle and initial velocity affect the range and Ymax of a projectile, create a model of a pneumatic launching system. And our essential question is, how can we design and construct a model of a launching system that will deliver a spherical projectile to a set location?
And when we talk about creating the launcher, we obviously, like when we are going to launch it, we have an example here. The angle is very important because if the angle is too low, it's not even going to hit the wall and go across it. So the angle is very important. And similarly, we are going to use the bicycle air pump for the pressure. That pressure is a science fact that we are going to bring in there. And that science fact of the air pressure is going to we are going to use that science, and then the measurement of the angle, the distance that's going to cover is going to be the vector, because we will be having the magnitude plus an exit, the horizontal and the vertical distance that the students will have to calculate. And we obviously have a rubric for the math, for the design, and the pre-design. So first of all, the students do create a virtual model using their presentations. When they are doing that virtual model, they are going through different websites that are already on our lessons. So once they do that virtual design, they are exploring different designs, not just this one, that we created a model. So we want them to think worldwide, not just limit to one model that we give them. And these are all the technical terms, like all the math standards. We try to incorporate the math and science standards to write the engineering understandings, but I try to make it simple and, related to the model that we have.
All right, so this is put into basically a 10-day unit, and these are the various activities that the students are working through in chronological order. So they're researching their solutions to the problem. We have a number of links to various places where they can do modeling and simulations as they work through their design. They have to develop a proposal within a budget. They do have to present this proposal.
And then they get into the hands-on part where they are building their working model. They test it, revise it. Our key here, really, with the vectors is that it is accuracy. These kids aren't trying to produce something that goes the furthest or the hardest or the fastest. They need to get it to a very specific target. And when they're all finished testing, revising, we have a technical report where they go through everything, and that's the final assessment for them on that. We have 2 examples here of how we're assessing with our rubric score sheets. We've linked this pretty tightly with English standards. As we have gone through this program, we've listened a lot to people from industry and how they said that these students really need to have the communication and the technical writing skills as well. So all of that is built into our assessment rubrics here, and why we put so much emphasis on that technical report after they finish with their design challenge. This is a screenshot of the all the technology that we integrated with this particular unit. So this would be available to anybody accessing our unit, and links to the various places where they can do simulations, research, and what they might be using.
Okay, so the engineering design challenge, they are actually building a pneumatic launching system that will launch a projectile over the DMZ between North Korea and South Korea to knock out a fictitious power plant that's on the North Korean side. And my students kind of had to tweak a little bit of it because it was going to be a ball projectile, but all of the PVC pipe ball was bigger than the ball. So we modified, and they actually did the dart instead of the actual ball. So they had to modify that a little bit. I think it worked better than the ball probably would have worked. And they went through all of the science part and the math part of figuring out how wide the DMZ is, how tall the fence is, and then they had to do the math to figure out the angle that they needed to launch. They had to make a scale model of how far it needed to go, and they had to hit a specific target. So a lot of the design or redesign part of it was them actually, after they got their model made, playing with the PSI, with the pressure of getting it to where it needs to go.
Also, it should be noted that when we designed this challenge, North Korea was a belligerent nation. And the mere knowledge that Georgia STEM students were on it ended the Korean War. Yeah, I think that's enough.
And
so here's
3 of them have taught it. 3, well, you're just about.
I finished the
right.
pre-assessment, so they already did the virtual design, and next week they're going to create these models.
And then Jason has, and
Yeah,
you
my
have
students,
2.
we went through the.
This is my students actually doing their part.
And the good thing is 50% of the materials that I needed, I got from local community people. So it was just a local community that works at plumbers, and we went to one of the tire walls, and then they gave us a bunch of tire walls and everything for free. So it was like we got good community service from there as well. And we are going to give them thank you cards with the pictures of the project that the students do. So like, they like to. So we are trying to bring in more community and spend less out of our pockets.
And you have a different launcher, right?
Yes, sir. What I did with my students, actually, I did not provide any material. So they had to come up with this on their own. Some of them created the different types of catapults, like you see here. The other one is like an overlay. And after we tested it yesterday, some of them they thought about maybe we can put like a small engine to make it work on its own instead of having the students actually push the. There's a kind of like
a winch.
Yeah, a winch. And that's design. You could click on the next picture. There's another model they created, like a typical catapult. And this other group, like artists, they created the model And the good thing, what they did, they used the software, the simulation, and they calculated the launching, angle, the distance, and then they tried to make it. Some of them, they found out after they tested out the catapult that the distance in the classroom was going to work. So only one group did it in the classroom, and then we had to move all to the courtyard and test it out there. And it was fun to see all the students from the school coming and watching. It was fun to see how the students adjusted and the scale. So really, we don't need to assume that the students know it, because I see like that a lot of students saw how the real the scale. They had to do it on figure out the scale on the real world. So you have to do a lot of measurement to figure out the scale factors and all that. And with regard to the angle of launching, how far the power plants from the wall, it was interesting to see them coming to bring in what they learned from the math and the science, and then looking at the design, the engineering design. It's a real life thing. You have to deal with constraints and with problems that happen, so you have to deal with that. And it was nice to hear that conversation.
That was it. Do you have any questions?
I have a comment that it might be interesting to include in the beginning of doing ballistics kind of things, when they would make the books for the guys firing the cannons and the tanks and all that. They had to have people do that. They didn't have simulators, so they had to have them do the actual calculations. And they just hired thousands and thousands of people just to run all these numbers for every type of armament, every type of shell they had. And those people were called computers. I don't know if you knew that. Yeah, some of you shaking your head, yeah. And then when they started, they made like ENIAC or UNIVAC, one of them, I can't remember which one it was. But they ran parallel with, it was mostly women that were computers. And then they ran these computers parallel with them to make sure, and then they finally just said, no, these things are working. So they called those electrical computers. That's the first, when they first started making those. So you might put that in there just as a historical touchstone for that.
I think Mike had a good point too. Will you talk to them about maybe now after we've done it, and 3 people have done it, to adjust our challenge?
So, I mean, one of the biggest parts of any kind of engineering design is going to be your funding and your materials, and y'all did a good job about it. On you can't just have everything available to you to get whatever you need it done. So, with them having 2 different ways, one being pneumatic, one being more of a catapult, you give the students a budget, and one of them is, of course, going to be a higher dollar amount, but more effective. So example would be pneumatic cost more, but they don't get as many rounds of whatever ammo they need because it's more accurate. Catapult's going to be cheaper, but they're going to have to purchase more rounds of ammo to actually hit the target because of it's a little bit more inaccurate. So anytime you can do that, where you can give them more options than they need, it's going to help be more of a real life scenario.
And you can use the budget to differentiate, to give the smaller budget windows, shrink it down to certain groups, maybe expand it for others, things like that.
Bang for your buck.
All right, so go ahead and go into your technology and rate. You have 10 minutes to do that. And then our next elementary group is up.
A number of tests with various parameters, plot everything, so you should be able to predict exactly where everything's going to be. When I actually took a class on software, I was that, but the way that we tested some guy in they called it the stop head, You vary everything. You're supposed to put all this thing in Excel. And it's supposed to be, it's a different period.
Yes. 11 days for that light unit versus so you've already talked. But the actual challenge should take about 7. So pretty much all of the different things are on this unit. We're having
About 5 minutes.
video lesson because we may or may not talk.
So y'all want to ready to go up and set up?
I mean, if you insist.
I just encourage.
This is so you can tell your friend.
Sure, yes, that would be lovely. Thank you. Look at us like
Smaller.
Good third party.
I haven't even practiced. What's the thing called? All right, you people are. Okay, so like 2 seconds ago, I found out I'm supposed to introduce this thing, and I really haven't been paying attention. But I can read the title. It's After the Perfect Storm. If I'm correct in remembering, the premise is there has been a severe weather event that has knocked out communication and is limiting travel. So the residents of this now devastated area have to develop a way of communicating using their understanding of light and sound. That sound good, ladies? Sounds awesome. Outstanding. I'll let you introduce yourself. It's the only one I can remember, Leslie.
I work with it.
Yeah.
I'm Brandy. I'm Lindsay, Caitlin, and Michelle Davis. Sorry, I'm the only one with last name. Just kidding. All right, so our unit overview. The students will understand that natural disasters may interfere with communication throughout their cities and communities. The students will learn about how light and sound travel through air, water, and the environment. Students will design a device using light and or sound to communicate, which will be tested and redesigned, and the students will have to use a budget to be able to choose their materials to make their device. The students will explore real-life engineering through the challenge and its effects on society's ability to communicate and the struggles engineers face each day when solving an engineering situation through the use of the design process. And some of the standards, this is more specific towards 4th grade. The science standards are the light and sound standards, but one of the main focuses on those standards is actually a big standard that actually ties in being able to create a device using light and or sound to communicate. So that's one of the big things of why we chose this. Math standards, using 4 operations to solve word problems. Shapes, understanding how things are shaped in an area. And then applying the area and perimeter formulas, being able to see how far or large an area is. We also are trying to connect it to ELA standards using the research, understanding what natural disasters, what destruction they can cause, and doing the research on that. And then also overall structure, what, ideas and concepts, what happens first, next, and last. And then social studies, doing the personal budget with economics and understanding how to purchase things and not overspend. The SQF reflections, we felt that our unit was accomplished or advanced in all the different areas, and we just highlighted these sections.
That was on the sheet, make sure we covered that.
All right, for the learning targets. So through our unit, the students will be able to answer the questions: how can communication be created when there is a natural disaster? How can they communicate with someone who might not speak their native language or is deaf or blind? They should be able to answer: how can you use light to communicate, and how can you use sound to communicate? They also will be able to answer how you can use operations to solve real-world problems to stay within a budget constraint, and how do you classify angles?
Okay, so the lesson May activities, I think we're going to go through this in a minute, and ours potentially seems quite larger than some that you guys have. But again, what our lesson has here is we go through teaching light, and we go through teaching sound. And so the 4th grade standards, what they have to know about light is reflection and refraction. Those are the 2 main things that they have to know. And that how light travels through objects and how you can redirect light. Through sound, they have to know what happens if you increase the speed or the strength of a vibration. How does that affect sound? And then the 3rd element of the sound standard is literally create a device using light or sound to communicate over distance. And so we tackled it as teachers to really have a unit to teach that standard. I mean, the standard itself is a STEM lesson, But so we go through each one of the units prior to that to teach light and to teach sound and what they have to know. So for light, we have an activity for light. They go through a lab to learn transparent, translucent, and opaque. That's part of the standard they have to know. We do a catch a monster activity where they use a laser and mirrors and multiple mirrors around the room to hit a target within teams on the wall. Investigation stations to really have hands-on learning of reflection and refraction. The other part of that standard is concave, convex lenses. And then light engineering, light design, what can we do with this? And then we had a light design, kind of a mini challenge here, a light design challenge that went there. And then within sound, we had a sound explorations activity, and then simple instruments lab to, again, work with that. And the two parts of that standard are increasing the strength, which increases the volume, and increasing the speed, which increases the pitch. And that's what the standard is. That's what these students are to learn now. And so we have activities with the pitch and volume. And all of those lessons are still doing the underpinning standards to do the STEM challenge.
Which leads us to kind of our daily lesson breakdown. Like she was saying, it is a pretty large unit. We actually have a 26-day unit. Well, I can explain it though. We have a 26-day unit. The first 12 days are specifically looking at light and all the different activities she had put with light. Teaching about transparent, translucent, and opaque. Teaching about convex and concave lenses. All goes into that 12 days. Then the next 10 or so days is sound. And we talk about the different sound aspects of the standard, looking at the pitch, the volume, and understanding vibrations. But then the last 7 days is the large STEM challenge that will take about 7 days, creating that device to communicate using light or sound during a natural disaster. So it can be broken down into smaller units to use if you choose not to do the whole 26-day unit.
Because at the end of the light, there's a mini STEM challenge, and at the end of the sound, we do the big one. So you could break it down into two different ones if you wanted to.
And to go off what they were saying, at the end of the unit, the final standard is to create a device to use light and or sound, and that's why we want to teach both of those standards in isolation to move up to this, so that students then could have a choice, because it depends on what scenario you're in and what disaster you're in and who you're trying to communicate with for what purpose as to what part of this you would want to use. So our STEM challenge says there's been a massive storm in the area and you are stranded in your home without power. You have to design a device to communicate a certain distance. It could be with your neighbors, emergent personnel, to get help, whatever, using light and or sound. That would be up to the students if they wanted to use light or sound or both. That was part of our differentiated instruction. They are also to stay within a $1,000 budget, and we have several different ranges of materials, so they could stay on the lower end and make their device, or they could spend more money and get a little more high tech and effective. And then can your team get the help in time? So they had several constraints that are attached on that daily lesson that we couldn't get to. That goes on there.
The real world connections with our unit is going to be the students actually taking and budgeting out money to purchase the supplies that they need. Changing the strength and just getting the students to understand that changing the strength or speed of vibration affects the sounds we hear daily, and how light interacts with different materials and how they affect the light that we see. The career connections, there's lots of career connections to our unit. We just a basic engineer and a basic scientist, but we want the students to know a little bit more about engineers. We don't just want them to know that we want them to understand that there's different types. And so the career connections with our project is an audio sound engineer, optical engineer, acoustical engineer, photonic engineer, I'm sorry, I said that again, so sorry, and electrical engineer. So we want them to know the difference between all of those and how they can connect to light and sound. And if they're interested in those, that maybe those would be some career paths they could take and choose one day. Questions?
Any questions?
How will they test their device at the engineering challenge? We actually have a rubric that they will have to follow and hit certain criteria when they test it within their either classroom, or we might take a larger scope outside, depending on the distance that we set for them. And we also have a pre-test and a post-test to determine their knowledge of the unit. And within those mini activities, we have rubrics for all of those as well, that gives them guidelines and things that they have to do within that activity.
But again, it is kind of similar to like the water and like the one that we did, like they did. It's a little bit of a watered down one where, okay, we have this certain amount of distance and there's some things in the middle, and you have to get a signal to there. So depending on how the teacher wants to do it, it could be from one room to another, because there's different things about how sound goes through opaque objects, and then also definitely the standard is light and or sound, but definitely those distances could be different. Good.
Thank
And by the way, who was it who had, which one of y'all had industrial designer as a career? Was y'all? That's what my degree said.
We want to go on record, the high school notice. We want to know after the perfect storm, is that where the spring ladies can?
Not much else.